Welcome to Ask and Learn.
All right, guys, we're doing problem number 52 of chapter 8 in Chemistry Central Science. So for each of these molecules, they want to write a Lewis structure that obeys the octet rule and calculate the oxidation numbers and formal charges of all atoms. So we're going to have this scenario. So oxygen, we have 18 valence electrons for oxygen. So we have 1, 2, 3, 4, 5, 6, 7, 8, and we're going to put our 9th lone pair here. That creates 18 electrons. So now we're going to find the formal charge. So the formal charge, that's going to be the number of valence electrons minus the sum of the number of bonds, and double bonds count as 2 bonds, triple bonds count as 3 bonds effectively, and the number of electrons in lone pairs. So 2 plus 3 is equal to plus 1. O1 is us, and we'll just assign this to the left. That's 4 plus this 2 is equal to 0. And the one on the right, O2, is 6 minus 6 plus 1 is equal to -1. So we also can assign our oxidation states. So the oxidation states is, you can think of it as like the theoretical charge you would have if these, basically the theoretical charge you would have if these molecules were bonded, were held together as in an ionic compound. So we can think, so for oxygen, its oxidation number, unless it's in a peroxide, is always -2. So -2, -2, and our overall oxidation number has to be 0 if we were dealing with a neutral molecule. So these are 2 minus, so that creates -4. So this should be +4. So let's do it like this. So now let's count the number of electron pairs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is the correct structure. Let's look at the formal charges. So 6 minus 6, because we have 1, 2, 3, 4, 5, 6 bonds, going to equal to 0. All these oxygens are equivalent, so we can just use this as one equation. So 6 minus 4 lone pair electrons plus 2 bonds is equal to 0. So the oxidation states of oxygen are -2, -2, -2, and this is going to be +6. So now let's go to SO3 2-. So it's going to look similar to what we have here. So I'm assuming the oxygens are going to be producing the charge we have here. And so we add 2 electrons to SO3 2- relative to SO3 because we got that 2- charge. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're missing a pair, so we're going to get rid of this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So let's look at our formal charges. So 6 minus 2 plus 3 is equal to plus 1. So all these oxygens are equivalent. So oxygen is equal to 6 minus 6 plus 1 bond is equal to -1. Now let's look at the oxidation states of these. So all these oxygens are going to be -2. S. S. So we know all of these oxygens have a -2 have a -2 oxidation state. So based on that, we can find the oxidation state for sulfur. And remember, our total oxidation state, that has to be equal to the oxidation state of our sulfur, that is equal to the overall charge of our ion. So let's put the oxidation. So -6 S plus blank is equal to -2. So that would so we can put -4 here. So that means the oxidation state of our sulfur here, that's going to be a +4. And that's how you solve this problem. So you have to have a good knowledge of the valence electrons. You have to know your rules for calculating formal charge. You have to conceptually understand the ionic structure, and like you can think of oxidation number as like how these molecules are bonded together. If you had like they theoretically all had these theoretically were all like ionically bonded together.